Hey folks, in this episode I'm going to show you how to make this audio visualizer in Blender. We're going to be using a combination of techniques to create this. We're going to use geometry nodes, the shader editor and the modifier stack to accomplish this look here. So without further ado, let's get to it. So open up Blender, we're going to go to Edit, Preferences and under Add-ons we're going to search for Node and then enable the Node Wrangler here. Once you've enabled that, we're going to click this button and click Save Preferences, and that will ensure the Node Wrangler loads every time we load Blender. I'll then close this window here. I'll then switch my render engine from Eevee to Cycles. I'm going to change my device type from CPU to GPU. I'll then go to my output settings over here, and I'm going to change my frame rate from 24 FPS to 30 FPS. I'll also enable render region. In my 3D viewport, I'm going to delete the default light, select the default cube and hit Ctrl 2, and that will add a subdivision surface modifier at level 2. I'll then navigate to my modifiers tab over here, and now you can see that we've got the subdivision surface modifier here. I'll then click this arrow and I'll click apply. I'll then click add modifier. I'm going to go to deform and we'll choose cast, and the cast modifier just ensures that this object conforms to a sphere. I'll then go to the cast modifier. I'm going to click this arrow and I'll click apply. In my outliner, I'm going to rename this object to Wobbles. I'll then hit Shift D to duplicate. I'm going to right click it back in its original position. I'm going to tab into edit mode. I'll hit S2 to scale by 2. I'll hit enter. I'll just hit numpad 7 to go into top view. I'll then toggle on X-ray view, and I'm going to box select all of these vertices here. I'm going to hit X and we'll delete the vertices. I'll then tab out of edit mode. I'm going to toggle off X-ray view. In my outliner, I'm going to rename this object to Reflector. In the outliner, I'm going to click the eye icon and hide that from the 3D viewport. I'll select the Wobbles object. I'm going to hit numpad 1 to go into front view, and on your modifier tab over here, we'll then click add modifier. We go to generate and we'll choose edge split. Decrease the edge angle by 0 degrees, and that should separate all the faces. I'll then go to my modifiers tab, click add modifier. We go generate and we'll choose subdivision surface. I'm going to set the levels for viewport and render to be 1. I'll then click add modifier. We go generate and we'll choose solidify. I'm going to change the offset to 1. I'm going to increase the thickness to 0.25. I'll also enable even thickness. We'll then click add modifier. We go generate and we'll choose subdivision surface. We'll navigate to that modifier and I'm going to set the render cuts to 4. In my 3D viewport, I'm going to right click and select shade smooth. And that's it for our modifiers, all except the geometry node modifier. Next up, we need to bring in the audio data into Blender. I'll be using my own beat for this tutorial. I'll leave a link to this in the description where you can download it for free. So the beat is 180 BPM and Blender is set to 30 FPS. So we need to calculate how many frames per beat we get. And that's so I can establish an M frame on my timeline down here. To calculate that, I'm going to use an FPS to BPM calculator. I'm going to use vjam.com, but you can use any FPS to BPM calculator. So on vjam.com, I'm going to click support. I'll then click AV BPM calculator, and we've got Blender set to 30 frames per second and my beat is set to 180 BPM. I'll then click solve and that gives us 10 frames per beat. My track is 4 beats over 4 bars, which gives us 16 beats, and 16 beats times 10 frames gives us 160 frames, and I want it to repeat twice, so 160 frames times 2 is 320. I'll then close this window here, and in my M frame I'm going to type in 320. In my timeline, I'm just going to hit home, and that just ensures we can see the whole timeline in the view. We'll then hit Shift A, we're going to go empty, and I'm going to choose single arrow. I'll then navigate to my outliner, and I'm going to rename this object to LF add for low frequency add. I'll then hit Shift D to duplicate and escape it back in its original position. I'll then navigate to the outliner, and I'm going to rename this to MF multiply for mid frequency multiply. I'll then navigate to my object data tab over here, and I'm going to change the size to, let's say, 2 meters. I'll then select the LF add empty object. I'm going to ensure that I'm on frame 1 on my timeline. I'll then navigate to my object data tab over here, and with the Z location transform set to 0, I'm going to add a keyframe here. I'll then select the MF multiply empty object, and with the Z location transform set to 0, I'm going to add a keyframe here. I'll then select the low frequency add empty object. I'll navigate to the top left of my 3D viewport until I see a crosshair. I'll then left click and drag across and open up a new window. I'll then change this from the 3D viewport to the graph editor. I'll just hit N to hide the N panel. I'll expand the LF add action options. I'll expand the object transform and select the Z location keyframe. I'll then go to channel and we'll choose sound to samples. Navigate and select your audio track. The one I'm using is Escape Jungle Drums Snippets Clean 180 BPM. Again, I'll leave a link to this drum beat in the description where you can download it for free. And now we just need to input the frequency range we want to filter out. We've got the low frequency empty object selected, so we need to filter out all the low frequencies. I made this audio frequency range chart for this series. And the low frequency range we're going to be using for this tutorial will be between 20Hz and 80Hz. So for the lowest frequency, I'm going to type in 20, and the highest frequency, I'm going to type in 80. I'll also enable accumulate because this is an add function. I'll then click sound to samples. And as you can see, anytime a frequency range between 20 and 80 Hz plays, it triggers the graph to accumulate over time in steps. And we can use this to drive a W factor on a noise texture, for example. I'll then navigate to my outliner and I'll select the mid-frequency multiply empty object. I'll then navigate back to the graph editor. I'll expand these options, expand the object transform and select your Z location keyframe. Click channel and select sound to samples. Navigate and select your audio track. Now for this empty object, I want to filter out the mid-range frequencies. And the mid-range frequencies I want to capture will be between 1000 kHz and 4000 kHz. And that should be rims and snares, for example. So for the lowest frequency range, I'm going to type in 1000. And for the highest frequency range, I'm going to type in 4000. And because on my outliner, I want this to be a multiply object and not an add object, I'm going to disable accumulate. I'll then click sound to samples. And as you can see in the graph editor, every time a mid-range frequency hits, we're going to get one of these spikes here, but it'll always reset back to 0, unlike the accumulate option, which grows over time. And a graph form like this is suitable for driving values between 0 to 1, for example. For now, we've finished with the graph editor. So I'm going to take my cursor to the top left of the 3D viewport until I see a crosshair. I'll then left click and drag across and we'll collapse that window. I'll then take my cursor to the bottom left of the 3D viewport until I see a crosshair. I'll then left click and drag up and open up a new window. I'll then change this from the 3D viewport to the geometry node editor. I'll then select the wobbles object. In the geometry node editor, I'm going to click new, and that will add a new geometry node tree there. I'll then hit N to hide the N panel. I'll then navigate to my modifier tab over here. I'm going to go to this edge split and click this arrow button here, and that should collapse the modifier. And instead of clicking all of these individually, we can just click and drag down, and that will collapse them all. I'll then take this geometry node modifier and I'm going to drag it all the way to the top of the modifier stack. In my geometry node editor, I'm going to rename the node tree to audio wobbles. I think I'll increase the geometry node window just to give us a bit more room. This node structure shouldn't be too complicated. It's a fairly easy system to build. I want to deform this using noise textures, and to deform it we're going to need a set position node. So I'm going to hit Shift A and I'm going to search for set, and we'll choose set position, and I'll pop that in between there. I'll then hit Shift A and I'm going to search for noise, and we'll choose noise texture. I'm going to change this from 3D to 4D, and I'm going to change the scale to 1. I'll then connect the color socket from the noise texture into the offset of the set position node, and as you can see, this entire thing has shifted by 0.5 on the X, Y and Z. So if I go to numpad 7, you can see it's shifted this way, and if I hit numpad 3 to side view, you can see it's also shifted this way. So I'll just hit numpad 1 to go back into front view. So we need to subtract this on the X, Y and Z by 0.5, and to do that I'm going to hit Shift A, I'll go to vector and we'll choose vector math, and I'll pop that there. I'll then change it from add to subtract, and to recenter it we need to subtract the X, Y and Z by 0.5. I'll then hit Shift D to duplicate that node, and I'll pop it in between there, and I'll change it from subtract to scale. And now with this scale value we can control the amplitude of the effect. I'm just going to keep this set to 1 for now. Maybe I'll just drag this group input over to here. I now want to be able to bring in the audio data into geometry nodes. That's easy enough. I'll navigate to the outliner and I'll drag this LF add empty object into the geometry node tree, and I'll also do the same for the mid-frequency multiply object. I'll box select these two nodes, I'm going to hit G and I'll bring them over to here. I'll then hit Shift A and we'll search for separate, and we'll choose separate XYZ, and I'll pop that there. I'll then hit Shift D to duplicate, and I'm going to bring this down to here. And for this top object info node, I'm going to connect the location socket to the vector socket, the separate XYZ, and I'll also do the same for this object info node. I'll then hit Shift A and I'm going to search for maths, and we'll choose math, and I'll pop that there. I'll change the function from add to multiply. And if you remember, the audio we baked into these two empty objects was on the Z location transform. So now we can use that Z location data to drive any of the parameters in here. So I'm going to connect this Z location socket into the top socket of the math node. I'll then connect the value from this math node into the W factor of the noise texture. And now if I were to hit play, you should see that your object is moving in time with the music. We can't actually hear the music at the moment, so we need to bring that into Blender. So I'm going to skip back to the first frame. I'll just increase my 3D viewport just for now. I'll then hit Shift A. I'll then select speaker. I'll then go to my audio tab over here and I'll click open, locate and select your audio track. It has to be the same track that you used before, and then click open. And now if you hit play, you should be able to hear your audio track. Excellent. I'll just reselect my wobbles object. I'm going to increase the geometry node window. So on this multiply node is going to increase or decrease how much this W factor changes. So for example, if I hit play here, you can see it's moving a little bit, but then if I increase this number to 4, for example, you can see that the rate of change is greater. So I'm going to set mine to 4 just for now. I want this object to morph and wobble even when the beat isn't hitting, and that will give the animation more of a natural flow. So to do that, I'm just going to hold down Control, right click and drag through this noodle, and that will disconnect that from the system. I'll then hit Shift A and I'm going to search for value, and I'm going to choose a constant value and I'll pop that there. I'll skip back to frame 1, and on this value node I'm going to type in hash frame divided by 250, and if I hit play you can see that this number increases over time. I'll just skip back to frame 1. I'll then connect that value node into the W factor of this noise texture, and I'll just hit play just to see how much it's wobbling. Okay, it's not wobbling enough, so maybe I can reduce this number to 100. So that'll be hash frame divided by 100. I'll then hit enter. I'll just hit play. Okay, it's moving a bit more. Excellent. So now we just need to mix these two together. So I'll box select these nodes here. I'll just hit G, bring these across. I'll then select this multiply node. I'm going to hit Shift D to duplicate, and I'll pop that in between there. I'm going to change it from multiply to add. I'll then connect the value from this multiply node into the bottom socket of this add node. I'll then hit play. Excellent, it seems to be working okay. Now I want to integrate the mid-frequency range into the circuit, and I'm going to use the Z value to drive the distortion factor on this noise texture. I want to see how the mid-frequency range affects the noise texture on its own, so I'm just going to hold down Control, right click and drag through this noodle, and that will disconnect that from the loop. I'll then connect this Z socket into the distortion socket of the noise texture, and if I hit play you can see how it's affecting it. I want to remap these values and be a bit more precise, so I can show you how to interpret these numbers using a map range node and a graph editor. So I'm going to hit Shift A and I'll search for map, and we'll choose map range, and I'll pop that in between there. I'll then increase my timeline and I'll change it from the timeline to the graph editor, and the frequency range we want to map is the mid-frequency range. So in my outliner I'm going to select the mid-frequency range multiply empty object. I'm going to ensure that I've got the Z location keyframe selected. I'm going to hold down Control, middle mouse button and just drag up. As you can see in the graph editor, the values go from 0 and they peak at around about 0.15. So we need to translate those figures in geometry nodes. So I'm going to select my wobbles object, and so on this map range node I'm going to set the from minimum to 0 and the from maximum to 0.15. I'm going to hold down Control, left click and drag across this noodle just to disconnect it. Now I don't want this value going from 0 to 1 or 0 to 20 or anything like that. So for the 2 maximum I'm going to set this to 0.25. So essentially we've remapped these values from 0 and 0.15 to 0 to 0.25. So the maximum values this distortion should reach will be between 0 and 0.25. So I'll then connect the result from the map range node into the distortion socket of the noise texture. I'll then change my graph editor back to the timeline. I'll decrease the timeline. I'll then skip back to frame 1. I'll then hit play, and you should see that the movement is subtle. I want the big movements coming from the bass kicks, so I'm going to reconnect the low frequency add function back into the W factor. And now if I hit play you can see everything's working in unison. Excellent. Next up I'm just going to go to my material tab over here, wobble. In my geometry node tree at the end I'm going to hit Shift A and I'm going to search for set material, and I'll pop that in between there. And for the material I'm going to choose that wobble material. I want to extract a couple of attributes which I can bring into the shader editor. So I'll hit Shift A and I'm going to search for store, and I'll select store named attribute. and I pop that in between the set position node and the set material node. I'm going to change it from float to color. And the attribute I want to capture will be from this low frequency add function. So if you remember, the low frequency add function accumulated over time, and that will be perfect for driving a hue factor. So I'm going to take this value socket here and connect this into the value socket of the store named attribute. I'm going to hold down shift, right click and drag through that noodle. I'll just hit G and bring this up. And in that store named attribute, I'm going to rename it to hue, and that's so we know exactly what this is meant to drive. I'll select the store named attribute. I'm going to hit shift D to duplicate, and I'll pop that in between the set position node and the store named attribute node. Maybe I can drag this up to here, and I'll drag this one down to here. Again, this store named attribute is going to be set to color and point, but for this one, I'm going to change the name to mask, and we're going to use this to mask emission in the shader editor. I want to mask out a noise pattern, but I don't want to use this noise texture here, so I'm going to select this noise texture. I'll then hit Ctrl Shift D, and that will duplicate the node whilst maintaining a connection to the previous node. But for this noise texture, I'm going to set the scale to 4. I'll also decrease the detail to 0, and I'll decrease the roughness to 0. I'll then connect the color socket from this noise texture into the value socket of the store named attribute set to mask. And essentially, this is going to have exactly the same animation properties as this noise texture, and that's because it's driven by the low frequencies and the mid-range frequencies. The only difference is the scale, detail, and roughness. So your node structure should look something like this. Before we move on to materials and lighting, it's a good idea to save your project. So I'm going to go to File, Save As, and I'm going to save my project as Like and Subscribe. Thanks folks, you absolute legends, and then click Save As. I'm just going to decrease the geometry node editor. I'll then take my cursor to the bottom left of the 3D viewport until I see a crosshair. I'll left click and drag up and open up a new window. I'll then change this from the 3D viewport to the shader editor. I'll just hit N to hide the N panel. I'll just delete this node, that's from a previous tutorial, Real Metal Colors, so I'll just hit delete. We now need to call up those two attributes which we stored in geometry nodes, so I'll hit Shift A and I'm going to go input and we'll choose attribute and I'll pop that there. I'll just increase this window. I'll take this attribute node, I'm going to hit Shift D to duplicate and I'll pop that down there. If you remember, in our geometry node window, the first attribute that we stored was called hue, so for the name in this top attribute, I'm going to call this hue. I'll then hit enter. The spelling has to be identical and it is case sensitive. The second attribute we stored in geometry nodes was called mask, so for this attribute node, I'm going to type in mask. Maybe I'll just toggle on material preview. I'll hit Shift A and I'm going to search for color and I'll select color ramp and I'll pop that down there. On the color ramp, I'm going to click this plus button once and I'm going to change this color to magenta. Maybe a cherry red, something around there perhaps. I'll then select this first flag and I'm going to change this to light blue. I'm going to hover my cursor over the color swatch and hit Ctrl C and that will copy that color. I'll then select this color flag and I'll hit Ctrl V and that will paste that color into there. I'll change the position of this flag to, let's say, 0.6. I'll then select the first flag and I'll change the position to 0.4. I'll then connect the factor from this mask attribute into the factor of the color ramp. And I'll plug the color socket from the color ramp into the base color of the principal BSDF. And now, if I were to hit play, you should see that that's changing with the music. Excellent. I'll just skip back to frame 1. I want the low frequencies to drive the color change of this material. And to do that, I'm going to hit Shift A. I'm going to go color, and we'll choose hue saturation value, and I'll pop that in between there. I'll then take this hue and bring it to 0. I'll then hit Shift D to duplicate that node, and I'll pop that in between there, and that should reset it back to its original state. I'll then take this hue attribute, which is driven by the low frequency data, and I'll connect this factor socket into the hue socket of the hue saturation value node. And if I hit play, you should see that the hue is changing with the beat. Excellent. I want the changes to be a bit more predominant, so I'm going to hit Shift A and I'll search for math, and I'll add a math node and I'll pop that in between there. I'm going to change this from add to multiply, and I'm going to multiply it by 3.333. So just a couple more nodes. I want to utilize the emission on the principal BSDF. So I'll hit Shift A and I'm going to search for color and we'll choose color ramp and I'll pop that there. I'll then connect the factor from this mask attribute into the factor of the color ramp. I'll then connect the color socket from the color ramp into the strength socket of the emission on the principal BSDF. I'll change the interpolation type on the color ramp from linear to ease. In fact, while we're at it, I'm going to change the interpolation type on this color ramp from linear to ease as well. I'll then change the position of this black flag to, let's say, 0.55. I'm going to drag this white flag across to around about there. Okay, excellent. To increase the strength of the emission, I'm going to hit Shift A and I'll search for math, and I'll add a math node and pop that in between there. I'm going to change it from add to multiply. I'll then increase the value to 25. Okay, we can see the emission a lot better now. Excellent. Maybe I can change the position of this white flag to, let's say, 0.6. And finally, I'm going to connect this color socket from the hue saturation value node into the color socket of the emission. Finally, on your principal BSDF, I'm going to take the roughness down to 0. And that's the material complete. Excellent. So I'm going to take my cursor to the bottom left of the 3D viewport until I see a crosshair. I'll left click and drag down, and that will collapse that window. I'll then toggle on rendered view. I'll then navigate to the world tab down here, and I'm going to set the strength of the world to 0 in the 3D viewport. I'm going to hit Shift A, and I'm going to go light, and I'll choose point. I'll then hit G, Z, I'm going to hold down control to snap it to the grid, and I'm going to bring it up 2 meters. I'll navigate to the light data tab over here, and I'm going to increase the power to 1000 watts. I'll then change the color to blue, maybe something around there perhaps. I'll also increase the radius to 1 meter. And with that lamp selected, I'm going to hit Shift D to duplicate. I'm going to hit Z to constrain it to the Z axis. I'm going to hold down control to snap it to the grid, and I'm going to bring it down to around about there. So that's negative 2 meters on the Z axis. I'll then go to my light data tab over here, and I'm going to change the color to orange. Maybe for the orange color, I can take the power down to 500 watts. I'm going to select my wobble object. I'm going to hit numpad 1, numpad period, and that will center the view to the active object. I'll then hit Control Alt numpad 0, and that will align my camera to the view. I'll then select my camera. I'm going to increase the focal length to, let's say, 70 millimeters. I'm going to go to my object data tab over here, and I'm going to ensure on the X location is set to 0, and for the Z location, I'm also going to set to 0. Ensure that your X rotation is set to 90, and Y and Z are set to 0, and I'm just going to drag this back on the Y location transform until everything's encompassed in the view. And in my outliner with that reflector object, I'm just going to unhide that in the viewport. I'll then select that object. I'm going to hit S just to scale it up so it's in frame. I'm going to go to my modifier tab over here. I'm going to click add modifier. We go to generate and we'll choose subdivision surface. And maybe I can set this to 2 on the viewport and maybe 4 for the render. And with that object selected, I'm going to right click and select shade smooth. On my geometry node window, I'm going to change this from geometry nodes to the shader editor. I'll just increase this window. With the reflector object selected, I'm going to go to my material tab over here, and I'll click this minus button just to delete any materials. I'll then click new. I'll rename this material to mirror. I'll then navigate to my shader editor. I'm going to decrease the roughness to 0 and increase the metallic to 1. And in the 3D viewport with the reflector object selected, I'm going to hit S, and I'm just going to scale it up to around about there. I'll then hit S to scale, Y to constrain it on the Y-axis, and I'm going to bring this in until it encompasses the entire view. Maybe something around there perhaps. Maybe I can hit S and just scale this down. S, Y, and I'll scale it out to around about there. I'll then hit Control A, and we'll apply the scale. I don't want the reflections to outshine this object. I want this object to be the main focus of the animation. So with your mirror object selected, I'm going to take the base color and I'm going to bring the value down to, let's say, around about 0.25. I'll just navigate into my render settings. I'm going to enable denoising for the viewport. And the noise threshold for my render, I'm going to set this to 0.25. Maybe for the max samples, just for a test frame, I'm going to set this to 128. I'll expand lights and I'm going to disable light tree. I'll also expand light paths, and I'm going to disable reflective and refractive caustics. I'll just toggle on material preview. I'll then navigate to my compositing tab over here. I'll click use nodes, or if you're using Blender 5 and upwards, click new. I'll then go back to my layout view. I'm going to hit Control S to save the project, and that should save this as a thumbnail. I'll then toggle on solid view. I'll hit F12 to render out a test frame. When that's finished rendering, click escape. Go back to your compositing tab over here. I'll then navigate to my view tab over here and I'll click fit. I'll just hit N to hide the N panel. I'll then hit Shift A. I'm going to go filter and I'll choose glare and I'll pop that in between there. I'll then change it from streaks to bloom. Maybe I can decrease the strength to 0.5. I'll go back to my layout tab up here. I'm going to toggle on rendered view and I'm just going to select a random frame. I'll then toggle on solid view. I'm going to hit F12 just to render out one more test frame. Okay, I'm kind of happy with that result, so I'll hit escape to close that window. I'm going to go to my render tab over here, and for the max samples I'm going to set this to 256. That should be more than enough for this scene. I'm going to set the noise threshold to 0.025. I'm going to select another random frame, maybe this one. I'll hit F12 to render out a test frame. Okay, I'm happy with that result, so I'm going to hit escape. I'll then navigate to my output settings over here. I'm going to go to output. I'm going to click this folder icon, select a file location where you want to save your image sequence, and then click accept. We'll then choose the file format. You can go with PNG set to RGB at 16-bit. That should be absolutely fine. But for me, I'm going to have a file format of OpenEXR with a codec of DWAA lossy, and that will decrease my file size whilst increasing dynamic range for post-production. We'll then toggle on material preview, skip back to frame 1, hit Ctrl S, and that will save your project with this thumbnail. I'll then toggle into solid view, and then it's simply a case of hitting Ctrl F12, and that will render out your image sequence. You'd then bring that image sequence and the audio into a video editor of your choice. I use DaVinci Resolve. Just ensure that the video editor is set to 30 frames per second, and then you just render it out as an MPEG-4 with a codec of H.264 or something similar. So join me on Patreon as a free member, and you'll have access to this file alongside other Blender files from previous tutorials. That's the tutorial in a nutshell. I hope you found this useful. If you did, please click like and subscribe. It really helps my channel. Have a great day, level up, and thanks for watching.